All right, I'm briefly going to show you how to estimate instantaneous rate of change using a graph, or using the graphical approach for estimating instantaneous rate of change. The concept is important. You're not actually going to go through the physical aspect of this very often. In fact, I may not assign problems with this since we're not actually in school this year. But here's the basic idea. Now, imagine that you were riding a roller coaster car, and that roller coaster car was coming down through the curve. The rate of change is really the way that your car would be angled as it travels along the track. Okay, so maybe this bigger graph here is a little bit better. So, your roller coaster car comes down through, and maybe it would be angled like this when it's on this part of the curve, and then it would be angled like this when it's on this part of the curve, and it would be angled like that on that part of the curve. The instantaneous rate of change is really the slope of the tangent line to a particular point, and that's kind of what you can imagine with the roller coaster car along there. Anyway, so if I come up to the graph up here, the tangent line, if I'm trying to estimate the instantaneous rate of change, the slope at x equals 2, basically you're going to come into your graph at 2, and you can kind of do a tangent line like that. I'm going to have to put this down for just a second. But you can see here that I've drawn that tangent line there like that, and anyway, basically you can estimate your slope using that line. Now, any 2 points on that line should give you the same slope. All right, so you don't want to pick a point like right here and a point super close to it because you can't really tell anything about that point. I would look for a place where the graph crosses the grid line, or where it crosses one of the grid lines in the graph. And so, for example, you can see down here it's going through the point 1, 1, and then it's going through the point 2, 4 there. Okay, so from the point 1, 1 to the point 2, 4. Or if you're going to estimate, estimate like over here. Maybe that's about 3. Let's see, we'd be going 1, 2, 3, 4, 5, 6, 7, 7.5, something like that. But anyway, I think doing the slope between these 2 points will be just fine. So the point 1, 1 to the point 2, 4. Slope 4 minus 1 over 2 minus 1 is equal to 3, okay? And that would be my estimated slope. If you saw the other video where I pick points and actually substitute them into the equation, looks like the actual slope is going to be closer to 4. So this is not a real effective approach, but that visual of the tangent line having the same slope as the graph at that point is a really, really crucial idea in calculus, which is why I wanted to show you this example.